So in question number 8, we're just going to practice writing a few more inverses, which is namely the exact same 2 steps that we followed in number 7, and just practice getting more comfortable with it, especially now that almost all of the problems that you're going to see in number 8 involve logs and exponentials, learning how those 2 things go together in the bigger world of opposites that we've been learning in algebra for years. Now, I'll recopy the steps just to make sure we have them. The first step of finding an inverse is to still switch the x and the y. The second step of finding an inverse is to get y by itself. So as I do question letter A, I need to think about those 2 steps in that order. First, y equals means it becomes x equals. Log base 9 will stay the same. Those parts don't switch, but the letter x becomes a y. So I see that and I tell myself, okay, that's switch x and y. Now I need to get y by itself. The only thing impacting the y algebraically is this log base 9. That's the only operation that's happening to the y. So that's the only thing I need to get rid of. I need to get rid of log base 9. And the way to get rid of a log is to write it exponentially. Remember, the opposite of a log is an exponential. So I'm going to put this in exponential form. Again, if you're not comfortable with having a log on the right-hand side, you can just quickly switch the problem around so that log appears on the left-hand side, but it's your choice. It kind of works out the same. Either way, let's focus on the exponential order of things. We know that 9 is the subscript, so that's the base, to the power of whatever's on the other side, so that's the x, equals whatever's directly attached to the log in the base, so that's the y. And now that I look at what I wrote, I realize, oh, y is by itself. I don't even have to do any more algebra. So y equals 9 to the power of x must be my inverse. You can always check, you can graph it in a calculator, you can check the answer key, you can do lots of different things to confirm, but it looks like we're good to go with y equals 9 to the power of x, because y is by itself, and visually, you can kind of tell this is right, because the opposite of a log is an exponential, so I'm expecting that in the inverse equation, I'll see that opposite operation. Remember how if you have a subtraction in an inverse equation, you end up seeing an addition in your answer? It's pretty common to recognize that the opposite of a log is always going to look exponential. And by that logic, I can predict in letter B. I know that it's currently an exponential, so I am willing to bet now that my answer is probably going to have a log in it. So let's see if that happens. First step, switch x and y. X equals 10 to the power of y. Now we want to get y by itself. It's being exponentiated. 10 is exponentiating the y. It's raising it to a power or an exponent. So the only way to get rid of something exponential is to write a log. Log base 10 of, and if you're not sure what to do, you can always rewrite the problem, 10 to the power of y equals x to switch the order of things, but it's going to have to be log base 10 of x equals y. If you're like, wait, Herbert, how did you know that order so quickly? It really comes from experience, but one thing you can do is build that little arrow pattern and just kind of mentally fill in the numbers as you say them to yourselves. 10 to the power of y equals x. Yep, that's what I had, so I know the order kind of works. Some people end up remembering that the x and the y switch positions. In other words, whatever was attached to the 10 is now on the opposite side, and whatever used to be further from the 10 is now close by in the log, so that works too. Either way, notice y is by itself. That's what we wanted. So we must have the inverse equation that we needed. Y is equal to log base 10 of x. And we're not surprised. We predicted that. We said that log base 10 was, or log specifically, was going to be the inverse of an exponential. So we're definitely not shocked there. The last examples that I'll do in letters C and D are basically meant to kind of shed some light on how we can deal with more complicated expressions. So take the time before you watch that last video to make sure that A and B make sense before we level up considerably to the next part. If you feel as though you get it and you want to do the next parts without watching anything, that's great too. I'll leave that decision up to you.